Does code completion help you? And I have a few of these. I might just go through only one. I have two others. But here's a study done when code completion fails, a case study on real world completions. The abstract reads, code completion is commonly used by software developers and is integrated into all major IDEs. Good completion tools can not only save time and effort, but may also help avoid incorrect API usage. Many proposed completion tools have showed promising results on synthetic benchmarks, but these benchmarks make no claims about the realism of the completions they test. This lack of grounding in real-world data could hinder our scientific understanding of developer needs and of the efficacy of completion models. This paper represents a case study on 15,000 code completions that were applied by 66 real developers, which we study in contrast with artificial completions to inform future research and tools in this area. We find that synthetic benchmarks misrepresent many aspects of real-world completions. Tested completion tools were far less accurate on real-world data. Worse, on the few completions that consumed most of the developer's time, prediction accuracy was less than 20%, an effect that is invisible in synthetic benchmarks. Our findings have ramifications for future benchmarks, tool design, and real-world efficacy. Benchmarks must account for completions that developers use most, such as intra-project APIs. Models should be designed to be amenable to intra-project data, and real-world developer trials are essential to quantifying performance on the least predictable completions, which are both most time-consuming and far more typical than artificial data suggests. So they looked at Visual Studio. They looked at things that were done with, I believe, neural network systems. I think training data, neural network training data, etc. And they looked at the types of completions that were being done and what developers chose to use and accept in terms of the completions that they would hit enter on, for example, that were generated for them, and then they would hit enter, and what the consequences would be. And essentially what the conclusion is, it highlights the fact that even though there are some benefits to code completions, there are other factors that are not accounted for in academic studies, which this study tried to do, such as when you have a code completion that is kind of out to left field, that doesn't have a very narrow or fine-tuned completion within something that you're working on. It is an auto-completion, perhaps generated by AI, where it essentially tries to guess at what you're doing, but it's not very clear what you're doing. And the programmer accepts such completions. There are fewer, they happen on fewer times, but when they do happen and they are accepted, it causes the developers far more time to discover bugs or performance issues as part of accepting those completions versus any other type of completion. In other words, while it happens fewer, bad auto completions, when they do happen, cause more problems than they solve. Now, the argument again would be, well, then just get good at understanding which completions to accept. Yes, except my argument is, going back, that auto completions themselves, AI, the automation of all these abstracted frameworks and whatever, do not help you to exercise your cognitive abilities to make a value judgment whether an auto completion is good to begin with. Most people could not make such a value judgment in today's tech industry, not because they don't have the brain power to do it, but because we've neutered them from doing it. And so this kind of a tool only feeds and perpetuates a negative cycle, especially when some of these problems go unnoticed for an unbeknownst amount of time until they rear their ugly head, such as we have gone over study after study after study, and this one was no different. Don't complete it. Preventing unhelpful code completion for productive and sustainable neural code completion systems, done in 2022. So even this study, even though it's generally positive and provides like a positive spin on like, here's things you can do to help you prevent from having problems with autocomplete systems, especially with AI, it still brings up some very important points. The abstract. Currently, large pre-trained language models are widely applied in neural code completion systems. Though large code models significantly outperform their smaller counterparts, around 70% of displayed code completions from GitHub Copilot are not accepted by developers. Being reviewed but not accepted, their help to developer productivity is considerably limited and may conversely aggravate the workload of developers, as the code completions are automatically and actively generated in state-of-the-art code completion systems as developers type out once the service is enabled. Even worse, considering the high cost of the large code models, it is a huge waste of computing resources and energy, which severely goes against the sustainable development principle of AI technologies. However, such waste has never been realized, not to mention effectively addressed, in the research community for neural code completion. Hence, preventing such unhelpful code completions from happening in a cost-friendly way is of urgent need. To fill the significant gap, we first investigate the prompts of unhelpful code completions called low-return prompts. We empirically identify 4 observable patterns in low-return prompts, each lacking necessary information, making it difficult to address through enhancements to the model's accuracy alone. This demonstrates the feasibility of identifying such low-return prompts based on the prompts themselves. Motivated by this finding, we propose an early rejection mechanism to turn down low-return prompts by foretelling the code completion qualities. The prompts that are estimated to receive unhelpful code completions will not be sent to the model. Furthermore, we investigated 5 types of estimators to demonstrate the feasibility of the mechanism. The experimental results show that the estimator can reject 20% of code completion requests with a 97.4% precision. To the best of our knowledge, it is the first systemic approach to address the problem of unhelpful code completions, and this work also sheds light on an important research direction of large code models. Now, this is great. I appreciate the positive spin on this. Can anybody see a problem with this? The dependency here is that you are relying on an industry which cannot produce quality code to begin with, nor appropriately value judge it. And you make a wide sweeping reliance that these people who are rejecting the code completions are the ones who can properly value judge them to begin with. And then, just to further exacerbate this issue, what you're doing is we're just going to automate away the problem anyways, so that people who cannot make proper value judgments to begin with now no longer have to make these value judgments. We'll automate the value judgment for you. I'm sure there's nothing that could go wrong with this. I'm sure that this will have nothing but positive impacts on programmers' abilities to be able to discern between quality code and non-quality code as produced by any AI system, especially when the marketing leans towards, don't worry, we've taken low quality code out of the equation because we've taken high trust programmers and use them as our data points for rejecting these code completions, so anybody who uses this thing can trust with a high level of accuracy that any code generated is high quality code. This is just dealing with symptoms by adding more symptoms. Nobody here is dealing with a cause. And even if they were, just the study itself indicating that Copilot rejections of automated code are rejected around 70% of the time is enough to warrant an eyebrow raise by all programmers everywhere. If nothing else, if none of my other arguments hold true.